Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is minimize sum. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You have an array A of n integers and an integer m is also given. The values in our array A will always be restricted between 0, that is, it will be greater than or equal to 0, and will always be less than m. We can do the following operation as many times as we want. In our array A, for all the elements, we can increment them by 1. So AI will become AI plus 1 and then modulus with the integer given m. And we have to do this for all the indices. So if we perform the operation once, all the elements in A will be incremented by 1 and then we'll have a mod, sorry, when we increment it by 1, all the elements will increment and then we'll take a mod of m for all of them. We need to find the minimum possible sum of our array A after doing some numbers of operation as many times. Now, for input format, we have t test cases, and for each test case, we will have two lines. The first line will contain two integers n and m. N is the size of our array, and m is the modulo given. On the second line, we'll have n spaced integers that will be a1, a2 till an. As for the output, on a single line, we just have to output the minimum possible sum after some number of operations. As for constraints, number of test cases will go from 1 to 10 raised to 4. Value of n and m will go from 1 to 2 into 10 raised to 5. And as we have discussed, the value of elements in array A will be greater than or equal to 0 but will always be less than m. Let's see some sample inputs. So for the first sample input, the value of n given is 3 and the value of m is also 3. And the elements in our array A are 2, 0 and 1. So now at this point, the sum is 3. Let's say we increment all of them by 1. So with increment of 1, this will become 3, 1 and 2. If we do a modulus with 3, 3 modulo 3 is 0, 1 modulus 3 is 1, and 2 modulus 3 is again just 2. With this, we are again back to 3. If we do another increment, this is the second time that we are doing, this will become again 1, 2 and this will become 3. If we do the modulo, it will become 1, 2 and 0. Again, the sum remains 3. You can keep going and we'll observe that after increment and doing the modulus, the sum always remains 3. That's why the answer here is 3. For the second case, we have two elements and the value of m given is 1000. The array with us is 1, comma 1. Now let's say we perform the operation 999 times. So if we do that, what will happen? They will all increase by 999, that will make them 1000, and 1000 modulus 1000 will be 0. The final array that we'll get is 0, comma 0, and the sum here is finally also 0. And as you can see, that's the answer here. Let's see how we can approach the solution. Let's take this array as an example. This will have some elements, and the m given to us is 6. It means all the elements in our array A will be greater than or equal to 0 but will be less than 6. So in this case, let's take it like this. We have 0, we have 1, we have 2, we have some 3, 2 fours, and a 5. Now what happens when we increment it and do a modulus? For that, let's take a frequency map. So our frequency map we are keeping at each number, at each index, how many numbers do we have? So if we see at 0 we have one number, at 1 we have two counts of 1, we only have a single 2, a single 3, we have two counts of 4 and a single count of 5. Now what will happen if you perform the operation once? If you are performing it once, all the elements are going to increase by 1. So for all the elements, let's discuss 5 later. So all the elements in the range 0 to 4, what will happen is they'll increase by 1. So 0 will become 1, 1 will become 2, 2 will become 3, 3 will become 4, and finally 4 will also become 5. What will happen with 5? 5 will become 6, but 6 modulus with 6 itself will become 0. So this will rotate back to 0. Now what happens if we do this k times? Let me remove this. So let's assume we are moving by k. So if k operations are being performed, right? So what will happen to the elements that are less than this? So for these elements that are m minus k minus 1, they all will increment by 1, right? And all the elements that are after this, so this k minus 1 elements that we have, right? This is k. So this k minus 1 element that we have, first of all, they will increment by k minus 1. And once they have incremented, pardon, since they all are going to reach 6, and once reaching 6, they will revert back, we are subtracting m minus 1 as well from all of them. Why? Because here they were moving just 1, so that's why we have added k minus 1. But once they cross 6, they become 0 and they lose all the values. And what is this? All the values that we're talking about? These are m minus 1. Because remember, m is 6. So we have m minus 1 and we subtract that. So how do we know what are the elements that are in this case less than k? So for that, in our frequency array that we have here, we can have a prefix sum. Once we have a prefix sum, we'll find out all the elements that are less than this k that we have here, that is m minus k minus 1. It will be nothing but prefix of m minus k minus 1. Let's call this y. These are the numbers that are not going to be affected by moving from 6 when we do the kth operation. What are the rest of the elements? Since these are the elements that are less, the remaining elements are nothing but n minus 1. So y elements are going to increment by k, and rest of the elements that are n minus y, they are first going to be incremented by k minus 1, and then we are decrementing them by m minus 1 as they cross the threshold of m. And if you simplify this, this is nothing but k minus m. So we'll do this for all the values of k, and whichever is the maximum, that will be our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. We take the input of n and m. Then we take the input of our array. Similarly, we create our frequency map. For that, once we take the input of an element, we increment its count in our array. Once we have this frequency array, we also need its prefix. So we convert this into a prefix by adding up its previous elements. Now once we have that, we know that our initial answer is nothing but sum of all the elements. Then we'll add up the difference that we got by incrementing different values of k. So we'll start from k value as 1 till m. So we'll find what are the elements, the count of elements that are less than k, that is nothing but m minus k minus 1. So these are nothing but we take the value from prefix. So these will be incremented by k, and remaining elements will be incremented by k minus 1 and then decremented by m minus 1. With this, we get the difference or the value that or the change that we get after doing k operations. So at the end, we add this change to our sum, and this is our answer. And as you can see, I've got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve. In solve, we take the input of our array, then we make our frequency array, we make it convert it into our prefix array. Then for each value of k, we find what will be the change after performing k operations. At the end, whichever is the minimum of these, we add to our sum, and as you can see, I've got an AC in my Python implementation as well. So I hope you got the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.